Hi everybody. So in today's video, I'm going to be programming, so I guess it's going to be the root mean squared error, but it's not really an error, it's an anomaly. So I'll just call it the root mean square anomaly. Um, so I have my autoencoder here, and this is the autoencoder with the memory component as part of it. So what I want to do is come over here first and do from mpl toolkits.mplot3d import axes 3D. So this is going to be so I'm going to come down here. I have my data set here. I'm going to do fig equals plt.figure, and let me go ahead and change some of this data around. Yeah, that should do it. Um, and then it's going to be ax equals fig dot add subplot one-on-one projection equals 3D. And then so I have the epochs here. I also need the learning rate. So LR is going to be equal to 1. So I'm going to come over here and do self.lr equals 1. Because these are going to be my x and y axis. Epochs are going to be the x and learning rate is going to be the y. Um, so then I'll come down here to the gradients. So when I am actually propagating them, um, okay, so this is what I have to do. Self.lr times gradient 1, self.lr times gradient 2, um, and then self.lr times gradient 3. Um, I don't want to print the epochs, um, but I will come down here and then do mem AI equals mem encoder of the length of data. Oh, wait a minute. I also need to, oh, no, yeah, this is the anomaly. So let's see what that anomaly will be. I will create a new variable called, let's see, I'm trying to find like where, okay, right here. So where it says, oh, so I already have self.anomaly, mean of error. Okay, okay, so self.anomaly. Okay, yeah, it's empty there. All right, okay, that's good. So then I will do mem AI.build. Hold on. Let me just double check that's what, yep, it's build. Um, so I took out the epochs. Okay, so I guess what I can do is on I need the root mean squared error, so okay, this is what I'm gonna do. So build, build, build. Okay. So I'm gonna do x, so no, or rather epochs equals 10, 50, 100, 200, 500. So it's 5. Learning, I'll call it learn equals 1, no, 0.001, 0.01, 0.1, 1.0, and 0.001. No, yeah. So then x and y are going to equal numpy.mesh grid of epochs and learning rate. So then it'll be z, or rather, I should call it RMSE equals numpy to zeros, length of learn, length of learn. Okay, so, oh yeah, might as well just do n equals length of learn. Okay, so I'm going to come here and do for I in range n, for j in range n. I will cut this out, paste this here. So then this will be epochs equals x of ij, learning rate equals y of ij, and then build that. And then what I'm going to do is RMSE. Oh wait, no. First, let me run the data. So mem AI, and it's going to take data. Yeah, data. And then I will do. So I want to do the RMSE formula. So root anomaly is going to equal the sum of for I in mem AI dot anomaly. This will be I minus the mean of mem AI dot anomaly. So the sum. Okay, so this is gonna be. Oh right, it has to be squared. Divided by the length of data. No. The length of mem AI dot anomaly minus 1. Okay, so I don't need that anymore. Um, I guess the square root. Root mean squared error. Okay, so now I will do RMSE ij equals root anomaly, and then I'm going to print I and j, and then I'm going to come here and do ax dot set title auto memory autoencoder root anomaly, and then ax dot set x label is going to be epochs. Ax dot set y label is going to be learning rate. Ax dot set z label is going to be anomaly, and then it's going to be ax dot plot surface of x, y, RMSE, C map equals HSV, and then plt dot show. So I'll come over here and do Python 3 viz auto. Okay, so it's going, and we got it. So we can see at the anomaly is highest when the learning rate is closer to 0, and the epochs are the highest. Um, so if we come over here, we can see that the anomaly is the lowest if the learning rate is 0 and the epochs are 0. And it's like, why would you run a machine learning model with just 0 epochs? So this one shouldn't probably even be like taken too much into consideration. Um, I guess what we'll do is, I guess I mean there isn't much to it. Um, So yeah, I guess that about it sums up this video. I thank y'all for watching this. I'm gonna keep coming out with more and more good machine learning content, so stay tuned and peace out.